This is called 4-step plus 1. The first step is f prime of x is equal to 0. Remember, that's just the derivative. Okay? If we think about the derivative as 2ax plus b equals 0, okay? Whereas ax squared plus bx plus c equals 0, right? That's the easy way to think about it, or you just do the derivative. And that's step 1. Step 2. Okay? So that's going to find you the axis of sim. Okay? Step 2 is going to be finding that axis of sim and plugging it in to give you the vertex. Okay? Step 3 is a really easy step. It's just finding the value for 0. Okay? So that's going to give us c every time, because c is right there. Because if x is 0, then these two go away, and you just leave with c. Okay? And then step 4 is going to be where we take the value of 2 of the axes. So we take 2 times the axis, right? And that should equal c also. So it's a nice, easy way to check your graph. So this is what I call the check step. Okay? Now, if they want the x intercepts, then that would be the plus 1, right? And the plus 1 step would be the quadratic formula. Okay, that would find your x intercepts. So let's do it. The first step is finding f prime of x. So f prime of x is equal to the exponent times the coefficient. 2 times -1 is -2, right? Take 1 away from that, that leaves 1. Then we take 1 times -8 is -8, right? Take 1 away, that's none, so there's no x's. There's no x's here, so that's really x to the 0, right? X to the 0. And then what is 0 times 13? 0, right? So that goes away. And so we're left with this 8, and then we set it equal to 0, right? And that's this step. So think about it. 2ax, 2 -1. 2 times -1 is -2x, plus b, plus -8. Plus -8 means -8. So either way you want to do it. Okay? Alright, now let's solve. So plus 8 plus 8. Okay, -2x is equal to 8. Divide by -2, divide by -2, I get x is equal to -4. That's my axis of sim. Okay? My axis of sim. So I'm going to move this graph to right here. Okay? And I'm going to think about this axis of sim as being 4. So I'm going to think about that as going, or -4, right? -4, so I'm going to go 1, 2, 3, 4. Did I hit record? Okay, good. I didn't remember doing that. Alright, so then boom, 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 boom. That's my axis. Okay? So it's the middle. That's the middle of it. Okay? So that's the middle of it. And so now I'm going to find out where it is. Where it is. Okay? So this is just -1, -4, right? Okay? And so now where is it? So I'm going to plug it in. So f of the axis, in this case -4, is equal to, and you plug it in, -x squared minus 8x minus 13, right? And so I plugged in -4, -4. So what is -4 squared? 16, right? But that's negative. Now, this becomes positive, but it's negative on the outside, right? Does anyone remember what that negative is telling us? Is it frowning?
Yes.
Yeah. So this is really, it's looking like this. Okay, so we kind of remember that, okay? So I got -16. What's a negative and a negative?
Positive.
Okay. 8 times 4? 32. Okay. And these should be halves of each other, right? Should be cutting. So we know we're on the right track. Because these are half, right? And then minus 13, right? And then I go, okay, well, that's half of that. So that's going to be 16 minus 13. What's 16 minus 13?
Negative.
So f of -4 is equal to 3, right? 16 minus 13 is 3. Right? Okay. So what that means is that I have a vertex. A vertex is at a vertex is at -4, 3. So at -4 and 1, 2, 3. And so I'm going to have this dot right here. And I know it's frowning, so it's going to look like this. Okay. Now, they asked for state the maximum number of turns, then sketch the graph, then state the real zeros, approximate each zero to the nearest tenth, approximate the relative minimum and maximum, right? And then to the nearest tenth. So, in this case, it's a maximum, right? It's a relative maximum because we know that it turns one time. Okay? It turns one time. We know that the one turn is a maximum because it's going like this. And the maximum is 3. The relative maximum is 3. Okay? And then we can graph it because it wants us to graph it. The easiest way to graph is, again, let's plug in f of 0. F of 0 just means that it's going to equal -13. Okay? So that means 0 and 13, or -13. That's easy. So then that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Let's just pretend. Okay? Well, went way down here. Right? So this is coming down to 13. And then over here should do the same thing. It should come, how far over though? How far over is this going to be? How many places am I coming? You know, how far? If this went 4 that way, and it's symmetrical, then we're going to come over 4, right? We're going to come over twice that amount. So I'm going to come over to 4 more, 1, 2, 3, 4, and that would be -8, right? And that better give me a dot right here. So it should come down, right? And give me that dot right down there. Okay? And so when I do that, that means that f of 2 times the negative 4 should equal negative 13. Right? And so what we do is we check it, just to make sure that everything's good. That means f of negative 8 is equal to negative 8 squared minus 8 times negative 8 minus 13. And so when we think about that, a negative and a negative make a positive, right? Plus 64. And then this is 64, and that's negative. So those are going to cancel, and it gives me 13, right? So this is right. That's my graph. My graph is good. Does that make sense?
Yeah.
Okay. Now, to fit it on your thing, we might not be able to go down 13, right? So you might want to change this to 2, 4, 6, right? So instead of this being 3, that becomes 6. So then 3 would be right here. And so that would be right here. And then it would go down to 2, 4, 6, 8, 10, 12, 14, 16. Oops. 16, 14. So right here. So it would just come down to that 13. So that way you can fit it on that graph that you got on your piece of paper. All right, now, but it wants all zeros. It wants all the zeros. That means it wants to know what these guys are. That's that plus 1 method, that quadratic formula, right? That means I've got to put in negative b. So remember, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? And then I got to plug that in. Negative b plus or minus the square root, so I'm going to get rid of that piece. The square root of b squared minus 4 times a times c. So times 4 times a times c all over 2 times a. Then I just start plugging those things in. B is negative 8. Okay? A is negative 1. C is negative 13. Okay? And then hopefully this number is not bigger than that number, because then we did something wrong. Okay? So negative makes a positive. That's 64. And then what's negative? That means minus, right? And what's 4 times 13? That's 40 plus 12, right? 40 plus 12? 52. Okay. All over negative 2. Okay? And so, what is 64 minus 52? Good. 12. All over negative 2. Okay. Now, so then we have, what is the square root of 12? Remember? So we take 12, we square it. 2 is 6, 2 is 3, and 3 is 1. And so we pull out that 2. So we really have 8 plus or minus 2 square roots of 3 all over negative 2. What goes in to 2, negative 2, and 8? What's in all of those numbers? 2. Not just 2, negative 2, right? So how many times does negative 2 go into 8? Negative 4. How many times does negative 2 go into 2? Once. Yeah, that just flips those. Positive becomes a negative, negative becomes a positive. It's the same thing, right? Okay, so once, square root of 3, all over. And how many times does negative 2 go into negative 2? Once. So that's our number. X is equal to, and so that's what these numbers are. And if we plug that in our calculator, what is negative 4 minus the square root of 3? Right? So we just go to our calculator. We go negative 4. Oops, clear. Negative 4 minus the square root of 3. And that equals negative 5.7. Okay? That's what this piece is. Negative 5.7. Looks about right. That's 4, that's 5, and almost 6, right? Okay, and then what's the other one? Well, that would be negative 4 plus the square root of 3. So we go negative 4 plus the square root of 3. And that's negative 2.3, right? And so, look, 2.3, look, it comes right across there. 2.3, okay? So that's perfect. So those are our points. Yeah. Perfect? All right. It's a lot of work for one problem, yeah?
That's why I hate these problems.
Yeah. This next one, let's use our Vertex Formula to do it, right? This one, is it smiling or is it frowning? Frowning. So it looks like this, right? Oh, we have two eyes, right? So it looks like this, okay? Now think about it. The only thing that's happening to it is it got flipped, right? It got flipped, right? And it got shifted. Plus 2. It got shifted up 2, right? So that means that 0, if I plug in a 0, it's going to come out 2, right? So that's what's going to happen here. It's going to go 1, 2. So this graph that used to look like this, 1 and 1, right? And then it goes up to 2 and 4, right? Okay? This graph, the only thing that happened to that x squared graph, right, is that it got flipped and then moved up to 2. So it's still going to go through this 1 and 1, and it's still going to go through the 2 and 4, but the 2 and 4 is going to be here, right, because it's 4 away from that point, and it's 4 away from that point. So now, this is my new graph. That's pretty easy, right? And then what are my points? What are my points that are going on here, right? So we got to know, what is x, what are my intercepts, and what is my y-intercept? Well, when I plug in a 0, f of 0, it equals 2. So that's my x-intercept, right? Or my y-intercept. My x-intercepts would be the quadratic formula again, right? Or negative b plus or minus the square root of b squared minus 4ac, right? Or in other words, when y is 0, if 0 is equal to negative x squared plus 2, think about that, right? So what I'm going to do is move the 2 over. So I got negative 2 is equal to negative x squared. Then I'm going to divide by a negative. And I get 2 is equal to x squared. That means that x is equal to the square root of 2. Plus or minus. Right? So that means, what is the square root of 2? Like 1 point something, right? So it's coming down 1 point something, 1 point something. That's what it is. And it's that easy. Lot easier problem that one was, right? Okay? Using our knowledge of the vertex, knowing that it's flipped because it's negative, knowing that it got shifted up. Okay? Now, in this one, we could also factor it if we wanted, right? Two things that multiply to be 14 but add to be 8. I don't know. Can we do that? No, because that's 2 and 7. So that's not going to work. We couldn't have factored that one either because they came out nasty. So we have to do this whole problem again. Okay? 3 minutes? Well, let's finish it. All right. F prime of x is equal to negative 2x plus 8 equals 0. Right? That means negative 2x equals negative 8. That means x equals 4. Sounds familiar. Plugging it in, right? F of 4 is equal to the negative 4 squared plus 8 times 4 minus 14. Right? So it's going to be 16 minus plus 32. Those are halves. That's beautiful. Minus 14. So it's like the only difference is really the 13 and the 14, right? Yeah. Okay. So then we're like, okay, so this is going to be 16 minus 14. So we got f of 4 is equal to 2. So our vertex is at 4 and 2, right? And then we've got to graph it. Well, because we know f of 0 is going to be negative 14. And f of 8 is also going to be negative 14. We'll double check it really quick because we're running out of time. What's 8 squared? 64, right? 64. Okay, and then that would be negative 64. What's 8 times 8? 64. So what's they subtract to be 0, right? So this is good. So we got 2 points here. We got 0 and 14, negative 14, and we got 8 and negative 14. Okay? So now we just got to graph that. Okay? So when I'm thinking 14, I'm going to go by 2s. 2, 4, 6, 8, 10, 12, 14. Right? And when I'm thinking 8, I'm thinking 2s also. 2, 4, 6, 8. Who do we appreciate? Dan. Go. Alright, so then, so we got 4. 4 and 2. So 4 and 2, let's put the 4 down here. 4 and 2 would be right here, right? And then it's going to come down to there. And then it's going to come over to there. Okay? We know one of our zeros is this. And then we have the negative